Alright, so the last part for probability that we'll learn about in this term, we'll probably learn a little bit more next term, but not a lot. So remember, we've learnt about sample space. We've learnt about how to calculate your probabilities using that formula that I told you about. Remember this bad boy here? Where is he? Okay, this formula. Okay, this will come in handy a lot. Okay, when it comes to calculating probabilities. And you'll remember yesterday when I started teaching you guys, okay, that we are going to be incorporating your fractions, a little bit of algebra and some ratios and that sort of thing, yeah? Now we're going to look into a little bit of that now with our tree diagrams, okay? So that's the next lesson on tree diagrams. So our intention for today is to be able to represent a sample space, okay, using a tree diagram, okay, and obviously get all the possible probabilities from there. Now the probabilities can either be fractions or decimals, right? So remember that. And the reason why we use tree diagrams is because sometimes you'll be able to determine more than one event, okay? You'll have multiple events happening here, so hopefully you'll be able to do that, more than one thing happening. Also be able to organize the outcomes of a tree diagram. That basically means I want you to be able to draw a tree diagram in this way that I'll show you. Determine the sample space, which is all the outcomes, and then obviously the probabilities for each thing happening or each outcome, right? So those 4 things, if you can do them today, good. All right, starting activity, we're not going to do this, okay? But just as a mental note, use your calculator for this, okay? On your calculator, if you just take it out, if you want to convert 0.5 into a fraction, so 0.5, okay, that's it there, yeah? You want to change it to a fraction, press FD. On your calculator, it could be S to D. Now, if you get that and you want to turn it into a percentage, anyone know how to turn percentage, a decimal to percentage? Times by 100. Yeah, just multiply by 100. There's your percentage. Okay, what about 0.12? What's that as a percentage? Times it by 100. Okay, there, 12%. What about 0.01254? Okay, what's that as a percentage? Multiply by 100. Okay, and it's 1.254%. Okay, so just keep that in mind. If you want to change that to, again, let's go back to 0.1254. And you want to change that to a fraction, just press FD. Okay, there. Just keep that in mind. You'll need that skill. All right, let's get into the tree diagram part and intro. So a tree diagram is an important way of organizing and visualizing. That's the main thing. You're not trying to be able to see or visualize what's happening with the probabilities and the information. Also, it's very useful, okay, when you've got multiple stages. So multiple different outcomes happening at different times. So it could be like one thing after another. So it could be, what's the chance of Todio buying KFC? And then from there, what's the chance of him getting a Zinger burger? And then from there, what's the chance of him getting a Pepsi for a drink? Okay, it's one thing after another. Okay, I love KFC, you can see that, right? When the information about probabilities is associated with each other, or each branch, sorry, that helps you to be able to computate or calculate probabilities. Okay, so the tree diagram basically will help you calculate your probabilities really easily. That's why we do this. All right, so let's have a look at an example of what a tree diagram has to look like. So these is basically, if you ever draw a tree diagram in my class and in year 11 and year 12, this is what it should look like. So you obviously have to have the tree itself, right there. Right? Make sure you include all the things in the tree. You've probably done this in year 9 and year 8, but include the tree. Okay. If it's multiple stages, include what's happening in that stage, and also include, okay, the probability for each branch. Okay. So here they've used decimals. That's okay. And the last thing is to include the outcomes in the end. Okay. So your tree diagram has to look like this. Right, like that. That's what it has to look like. Right, any tree diagram must look like this. And then we'll go through together how it works out. So as an introductory task, here's a question. We're going to do booklet number 4, okay, for this. Booklet task number 4. A family that comprises of 7 children. So you've got a family that has 7 kids. Anybody here have a family with that many kids? Probably not nowadays. My dad's family, sorry, he's got 7 brothers and 2 sisters. Each one has 3 kids. That's a lot of kids. for a lot of people. Lot of big Christmas families. Yeah. Anyway, so if we assume that having a boy or a girl is equally likely, how unusual is it? Where did my mouse go? How unusual is it for a family with 7 children to have 7 boys? Okay, so we're going to try and figure that out. What is the chance of a family having 7 boys? When mathematicians have a difficult problem like this, they usually have to solve either an easier one first. So let's start by having a smaller family of 3 children. If you consider 2 boys and 1 girl in any order, okay? So how many different possible families are there, and how could we represent that, and how could we calculate that? So we're going to use a tree diagram to do this. So we're going to go to activity number 4 in our booklets, which looks like this. Okay, so let's go to this question here, guys. Sorry. Okay, let's go to this part of the booklet. So let's start with making a simpler problem here. If you have a family of 2 boys and 1 girl, how many different possible combinations can you have when you give birth to them? So what that's saying is you can either have, so you've got to have 2 boys and 1 girl, right? So that means you could have had boy, boy, girl first as one outcome. That's one. What's the other outcomes? Anyone know? Or can anyone maybe come up with some more?
Girl, boy, boy.
Girl, boy, boy. So GBB. What else? BGB. Very good. Anyone else? That's really it, isn't it? You can't have any more. So that's one. Well, actually, that's all the possible combinations that you could have. Boy, boy, girl. Girl, boy, boy. Or girl, boy, girl. Okay. How do we represent this? Okay. So if you were to have, for the lady, actually everybody is going to hopefully have kids one day. How do you represent this as as data in a tree? So what you need to do, okay, is when you have a kid, right, you can either have a boy or girl, yeah? So if your mum had you, you're either going to be a boy or a girl. So let's start that off. Possible outcome was either boy or girl. And we call this maybe child 1. Child number 1. Okay, so copy this down, please. Child number 1. Now, have a think about it. If you have a kid and you only have either option boy or girl, what's the probability of getting either or? 50-50, yeah? So you can write it as a fraction or you can write it as a decimal. I'm going to use a fraction. So you have 1 in 2 chance of getting a boy or getting a girl. Okay, let's do another one. So your mom and... I won't go there. But they have another kid. Okay, so this is child number 2. Give yourself space to do this, yeah? So boy, girl, and then boy, girl. All right, and you have a 1 in 2 chance again of this happening. So this is how you construct your tree diagram. We should have probably given you more space for this, yeah? And then you could repeat it again for child number 3. It just means that you might have to make it a bit smaller, but child 3. Okay, so you've got boy, girl, boy, girl, boy, girl. Sorry for the spacing. And then boy, girl. And again, you have a 1 in 2 chance for all of them. I know it's a bit tedious, but you do have to put this in because it counts towards the marks for this question. Okay, so in the SAC or the CFAT or the exam, make sure you put everything in there. Okay, so that's one aspect of it. We haven't quite finished just yet because now we need to write down all the outcomes. So the outcomes are what comes in the end here. I'll use another color to do the outcomes. But for outcome number 1, the first one, if you have 3 kids, obviously what you do is you just follow the tree in the direction that it goes. So for that first one, it's boy, boy, boy. So 3 boys. So for that means the first outcome, 3 boys. Okay, lovely. Next one is boy, boy, girl. Just follow the tree. Boy, boy, girl. Third one, boy, girl, boy. Right, so B, G, B. Fourth one, boy, girl, girl. Lovely. B, girl, girl. And then now we get down to the bottom half. So it's got girl, boy, boy. So G, B, B. Next one is going to be girl, boy, girl. So you have to put these in. Second last one is girl, girl, boy. And last one is all three girls. I feel sorry for the dad. I'm kidding. That's lucky. That's a blessing. That's a good thing. Okay, so this is how we represent all the possible outcomes. Okay, now in terms of calculating this, okay, for the last couple of minutes, in order to calculate the probability for this, so if you forget all this, it's going to be recorded. So I want you to watch this again if you forget it. In order to calculate, for example, 3 boys, all you have to do is multiply the outcomes together. All right, so just multiply them all. So that means for this one, to get all 3 boys, it's going to be a half times a half times a half, which equals 1/8. Okay. It's the same process for even the second one, boy, boy, girl. So a half times a half times a half. So all these 3, multiply them together. Okay, and what you'll find is because they're all essentially a half, okay, it's all going to be a half times a half times a half for all of them. Okay, and that's basically how you calculate all the probabilities for each of these outcomes.